Antidifferentiation
by Kelly Thompson,
Kaylee Shannon,
Aaron Cassidy, and Finn Desmond.
An integral is a function of which a given function is the derivative, which yields that function when differentiated, and which may express the area under the curve of a graph of a function.
When given a function to integrate, you should end with an exponent 1 greater than what you are given. To do this, add 1 to the exponent, then divide the function by the new exponent. An example would be the integral of 2x dx, which equals x squared, plus c.
Now, what is plus c? When integrating, a siren should go off in your head to always add plus c.
Woo woo! Just like there is the chain rule in deriving, there is u substitution in integrating. U is always the inside function, so in this problem, 2x plus 3 is u. Then find the derivative of u, which is 2 dx. The 2's cancel out and you are left with the integral of u cubed du. Integrate to get 1/4 u to the 4th plus c. Then replace u with 2x plus 3 to get your final answer.
Given the same problem without the 2, you need to move a 1/2 to the outside of the integral because du is 2 dx. Integrate like you did in the last problem, but don't forget to distribute the 1/2 at the end.
There are two fundamental theorems. The fundamental theorem of calculus is f of b minus f of a. The second fundamental theorem is 1 over b minus a times the integral of a to b of f of x dx.
Here is an example of the first fundamental theorem. First, integrate the function, then plug in 3 and 1 into the integrated function, then subtract what you got from plugging in 1 from what you got from plugging in 3 to get your final answer.
You can use the second fundamental theorem to find the average value. As seen in this problem, you integrate normally and multiply by 1 over b minus a.
When an x value is given as a boundary, you must plug it into the equation and multiply by the derivative of the value as shown.
When there is an extra x that does not cancel out, you must solve for x in terms of u after finding your u. Then replace the x in terms of u and distribute as shown, and integrate normally from there.
In order to understand trig integrals, you must know trig derivatives. Memorize these so when you see them in an integral problem, you'll immediately be able to identify the answer. Here's an example of using the fundamental theorem with trig. Here's an example of u substitution with trig.
When using a graph for integration, find the area under the curve of the function within the restrictions, and make sure to account for the negative areas. Integrals can be negative, but area is always positive.